Hello, welcome to Majestic School. Today we are going to deal with distances, calculating distances between 2 points in our maths class. The last time we had a class, we dealt with a few things like the square. We talked about the square, like talking about a square because it's useful. I knew we were going to use a square to deal with the issue of Pythagoras theorem. Then we went further to talk about a right angle triangle and the Pythagoras theorem. You can check on our video. We also talk about the Cartesian graph and identification of points on the Cartesian graph. We talk about it. We mention that to identify a point on a graph or on a Cartesian graph, that you need two coordinates. You need two coordinates to be able to get a point. And the coordinates are created by tracing our line on the x-axis and on the y-axis. But today we are going to move a bit further by trying to find distances on these distances on the point. I've been able to create our y-axis here, and I've been able to create our x-axis here. This is our y, and this is our x-axis, y-axis. Now, we want to calculate the distance on this side. You know that this place is point B, this place is point A, point B, and point C here. So we want to be able to calculate this distance here. This distance, the line BC. Let us name this line BC that we want to calculate as our A. Remember our A when we were dealing with our Pythagoras theorem. This is our A square, and this side is B square, and this side is C square. So if we have it this way, and this time we are going to use the formula, using our Pythagoras theorem formula. We say that the square on the hypotenuse side, is equal to the sum of the square on the opposite and the adjacent side. The square on the hypotenuse side is equal to the sum of the square on the opposite and the adjacent side. So we say A square is equal to B square plus C squared. Now, this is our Pythagoras theorem. We will use this to see how we can get our points in each of these square. We get our point for each of these square, then use it to calculate our distance. So let us assume that this distance BC, the distance BC is our A square. The distance BC is our A square. So if we say it's our A square, it also represents our distance. So we say our A square is the same thing as our distance BC. Then our B square is also representing this distance AC. This distance AC. and we represent it on the y-axis, we were able to point it out, extend this line AB rather, line AB, we extended it to this point where you have your y1, beginning from this origin. This is our origin. That is our origin. This point is our origin. So this is y1 and this place is y2. So that covers our distance AC. Then this one is our x1, that is this point here, is our x1, and this point is our x2, because it's lying on the x-axis. The distance here is also lying on the y-axis. So if the distance here is b squared, we have it as y2 and y1, or y1 and y2, representing the distance here, and we have this one as our x2, x1. So we say C here now, this place C. So we can say, if you like, you use this one, but it's better to use this one first. So we now say C, we have our x2 plus, our x2 minus x1 or squared plus our y2 minus our y1 all squared. So this is the formula. We have only represented the distance. This is the formula. It's as simple as that. So we'll go further to say that our A is equal to the square root of x2, that is subscript 2, minus x1 all squared plus y2 subscript 2 minus y1 all squared. So the reason why I don't have my square here anymore is because of this square root. Introducing this square root will make me to remove this square on the left hand side of this equation. So this is our distance. This is how we are going to calculate our distance. So in calculating this distance, let us assume that our point here, our point B and our point C, we want to now calculate them. Let us assume that our point B is 3, is x-axis from here to this place is 3, 2. That is what has created this, the 2 points, the 2 coordinates that created this point B. Then this one is our 4, or let's assume so, it's just assumption. Our point C is our 4 and 6. Now we are going to say, if you are to subtract them, remember that the first one is this B is equals to 3, 2. C is equals to 4, 6 is all assumption. We are assuming the drawing may not be exactly what we have said, but it's just assumption. Some other time we can do that. Now let's assume that this one is our x1 and this one is our y1, and this one is x2, y2. I said 3, 2, x1, y1, 4, 6, x2, y2. So if we want to now fix it up here, substitute it for all this, we can go further to say A is equal to the square root of, remember you have x2 here, x2 minus x1. So we go for x2. Our x2 is 4. So we say 4 minus our x1 which is 3, all squared, plus y2 is 6, 6 minus our y1 is 2, all squared. Now, we now have our distance A is equal to 4 minus 3, square root again. 4 minus 3, we have 1 squared, plus 6 minus 2, we have 4 squared. So our distance A is equal to the square root of 1 square is 1, plus 4 squared is 16. So the final answer is square root of 16. Square root of 17. Final answer is square root of 17. So our final answer, you can leave it in this form, in root form or in surd form, or you go further to say plus or minus 4.123 if you wish to go further like this. So this is the answer of this calculation, and I want you to subscribe to our channel, click onto the notification bell, and share this video so we can make comment. Tell us certain topics you are struggling with in maths, in physics, in chemistry, so we can treat them. We want to encourage you and encourage us as well, so we can do greater work. Thank you very much, and God bless.